Hello everyone, it's Sarabjit Singh. Today we're going to learn about network management functional grouping. Network management functional grouping. Network management is a critical aspect of maintaining and optimizing modern computer networks. It involves the planning, monitoring, provisioning, and maintenance of network resources to ensure that they operate efficiently, securely, and reliably. Network management plays a crucial role in keeping businesses and organizations connected, productive, and secure in today's interconnected world. Definition: network management refers to the process of overseeing and controlling a computer network to ensure its proper functioning, performance, and security. It involves a combination of hardware, software, policies, and procedures aimed at managing network infrastructure effectively. Network management functional grouping refers to the categorization and organization of various network management tasks and activities into specific functional groups or domains. These groupings help streamline the management of complex networks by breaking down the responsibilities into manageable and specialized areas. Here are common functional groups in network management: fault management, configuration management, performance management, security management. Fault management is a crucial aspect of network management that involves detecting, isolating, and resolving issues or faults within a computer network. Here are some key components and techniques involved in fault management. 1. Fault detection. Network administrators use various monitoring tools and techniques to detect abnormalities, errors, or failures in the network. This can include monitoring network traffic, device performance metrics, and event logs. 2. Alarm generation. When a fault is detected, alarms or alerts are generated to notify network administrators. These alarms can be in the form of notifications, emails, or SNMP traps. 3. Alarm correlation. In larger networks, multiple alarms may be generated simultaneously. Alarm correlation techniques help in identifying the root cause of a problem by analyzing the relationships between different alarms and events. 4. Fault isolation. Once the fault is detected and correlated, network administrators need to isolate the problem to determine its scope and impact. This may involve isolating a specific device or segment of the network. 5. Troubleshooting. Network administrators use troubleshooting techniques and tools to diagnose the exact cause of the fault. This can involve analyzing configuration settings, checking hardware components, or running diagnostic tests. 6. Fault resolution. After identifying the root cause, network administrators take steps to resolve the fault. This may include reconfiguring devices, replacing faulty hardware, or applying software patches. 7. Reporting and documentation. It's essential to document all fault-related information, including the steps taken for resolution. This documentation helps in future reference and can be valuable for improving network reliability. 8. Automated fault management. Many modern network management systems incorporate automation to streamline fault detection and resolution processes. Automated scripts and AI-driven tools can help detect and resolve common issues more efficiently. 9. Redundancy and failover. Implementing redundancy and failover mechanisms in the network infrastructure can help minimize the impact of faults. This includes redundant hardware, load balancing, and failover configurations. 10. Continuous monitoring. Fault management is an ongoing process. Network administrators continuously monitor the network for potential issues and apply preventive measures to reduce the likelihood of faults occurring. Effective fault management is crucial for ensuring the reliability, availability, and performance of computer networks, especially in complex and critical environments. Configuration management is the practice of systematically managing and controlling changes to an organization's infrastructure, software, hardware, and documentation. It ensures that all components and resources within an organization are properly documented, tracked, and maintained. Here are key aspects of configuration management. 1. Configuration items CISA. These are the individual components of a system, such as hardware devices, software applications, configuration files, and documentation. Each CI is uniquely identified and managed within the configuration management system. 2. Configuration baselines. A configuration baseline is a snapshot of the configuration items at a specific point in time. It represents a known stable state of the system or component and serves as a reference for future changes. 3. Version control. Configuration management includes version control to track changes to software, firmware, and configuration files. Version control systems help ensure that changes are documented, reversible, and traceable. 4. Change management. Change management processes are integral to configuration management. Any proposed changes to configuration items, such as software updates, hardware upgrades, or system configurations, should go through a structured approval and testing process. 5. Documentation. Comprehensive documentation of CS, their relationships, and their configurations is essential. This includes hardware specifications, software licenses, network diagrams, and configuration settings. Documentation aids in troubleshooting, recovery, and compliance. 6. Automation tools and scripts can help in managing configuration changes efficiently, especially in large-scale and complex environments. Automated provisioning and deployment can reduce the risk of human errors. 7. Compliance and auditing. Configuration management ensures that systems adhere to regulatory, security, and compliance standards. Regular audits help verify that configurations remain in compliance with established policies. 8. Incident resolution. Configuration management provides a reference for troubleshooting and resolving incidents. Teams can compare the current configuration to baselines to identify deviations that may be causing problems. 9. Asset management. It helps organizations keep track of their IT assets, including hardware, software licenses, and warranties. This aids in resource planning, budgeting, and asset optimization. 10. Security. Configuration management plays a crucial role in cybersecurity by ensuring that systems are configured securely and that security patches and updates are applied promptly. 11. Scalability. As organizations grow or evolve, configuration management practices can help manage the complexity of scaling infrastructure and services. Configuration management systems, CMS, and tools such as Ansible, Puppet, Chef, and Microsoft SCCM are commonly used to implement these practices. They provide the Performance management is a comprehensive process that involves planning, monitoring, developing, and evaluating an individual, team, or organization's performance to achieve specific goals and objectives. It is a crucial practice in various contexts, including business, education, healthcare, and government. Here are key components and principles of performance management. 1. Goal setting. Performance management begins with setting clear, specific, and measurable goals and objectives. These goals should align with the organization's mission and strategic priorities. 2. Planning. Once goals are established, a performance management plan is created. This plan outlines the strategies, resources, and actions required to achieve the goals. 3. Monitoring and measurement. Continuous monitoring and measurement of progress are essential. Key performance indicators, KPIs, and metrics are used to assess performance against established goals. This may involve regular data collection reports and dashboards. 4. Feedback and communication. Regular feedback and communication between managers, supervisors, and employees are crucial. This includes providing constructive feedback, discussing performance expectations, and addressing concerns. 5. Performance appraisals. Periodic performance appraisals or reviews are conducted to assess an individual's or team's performance over a specific period. These evaluations often lead to discussions about areas for improvement and development. 6. Recognition and rewards. Recognizing and rewarding high performance can motivate individuals and teams to continue their efforts. Rewards may include salary increases, bonuses, promotions, or non monetary recognition like awards and praise. 7. Development and training. Performance management identifies areas where individuals or teams may need additional training or development opportunities to enhance their skills and capabilities. 8. Corrective actions. If performance falls below expectations, performance management may involve identifying the root causes and implementing corrective actions. This can include additional training, coaching, or performance improvement plans. Security management encompasses a range of practices and strategies aimed at protecting an organization's assets, including information, physical facilities, personnel, and technology, from various threats and risks. It's a critical component of overall business management. Here are key aspects of security management. 1. Risk assessment. Security management begins with identifying and assessing potential risks and threats to the organization. This includes conducting risk assessments, vulnerability assessments, and threat analyses. 2. Security policies and procedures. Establishing comprehensive security policies and procedures is crucial. These documents define security standards, guidelines, and best practices that employees must follow. 3. Access control. Managing access to physical facilities, computer systems, and data is fundamental. Access control mechanisms, such as authentication, authorization, and biometrics, help ensure that only authorized individuals have access to sensitive resources. 4. Data protection. Protecting sensitive data is paramount. Encryption, data classification, and data loss prevention (ADLP) strategies safeguard data from unauthorized access, disclosure, or theft. 5. Security awareness training. Regular training and awareness programs educate employees about security threats, best practices, and their roles in maintaining security. 6. Incident response. Developing an incident response plan is essential for addressing security incidents, breaches, or emergencies promptly and effectively. 7. Security monitoring. Continuously monitoring systems and networks for suspicious activities and anomalies is vital for early threat detection. Security information and event management (SIEM) tools are commonly used for this purpose. 8. Security audits and compliance. Conducting regular security audits and assessments helps ensure that security measures are aligned with industry standards and regulatory requirements. 9. Security technology. Implementing security technologies such as firewalls, antivirus software, intrusion detection systems (EIDs), and intrusion prevention systems (IPs) helps protect against various cyber threats. 10. Physical security. Physical security measures such as access control systems, surveillance cameras, and security guards safeguard physical facilities and assets. 11. Business continuity and disaster recovery. Preparing for and mitigating the impact of disasters, including natural disasters and cyber attacks, is a critical aspect of security management. Business continuity plans and disaster recovery plans outline how to maintain essential operations during and after disruptive events. 12. Security governance. Establishing clear security governance structures ensures that security is integrated into the organization's overall strategy. This often includes the appointment of a Chief Information Security Officer, CISO, or equivalent role. 13. Vendor and supply chain security. Ensuring the SEC.
इसमें नाम सही से नहीं बोला, वो सरबजीत है, दूसरा कुछ नहीं। ठीक है, राम राम।